Alright. Well, I need to introduce a new concept, a new mathematical tool called the characteristic sequence. Now, I won't wave my hands and give you a vague definition. I'll just plunge straight in and give you a concrete example, and then you'll see it better. Now, those of you who follow lectures in the French tradition, I hope, it's been a while since I've lived in French culture, but I hope your French professors have learned, when you're trying to learn a new concept, you don't give the abstract definition. It's meaningless because you haven't a clue what the definition is about. So you start with a concrete example, right? So I hope French professors and those colonies of France who have absorbed the same tradition of definitions first and examples second have unlearned that bad habit and gone the other way. So, okay, what is a characteristic sequence? Well, here's an example. Here's sigma star, the infinite set of all possible strings of sigma, right? The alphabet. Okay, here they are listed, of size 1, of size 2. Oh, we're doing for binary. Yeah, okay. So this is just 0 or 1. Okay, so here's a list of all possible binary strings of a given length. So we have 2 of length 1, we have 4 of length 2, we'll have 8 of length 3, and so on. Okay. And here is a language. Remember, a language is a set of strings. And in this case, the language is binary strings where the first digit is a 0. Okay? So 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, so on. Okay? So A is the language of binary strings where the first digit in the string is a 0. Okay? Okay. Now, here is a characteristic sequence of this language. Okay? And it's written chi, the capital chi, Greek letter chi, with suffix a. So this symbol here, it means it's the characteristic sequence of the language A. Now, what is a characteristic sequence? Well, what you do is you look at these two lists, and you look at the first member of this infinite list, and you look at this one and you look at this one. Now, if it's not here, if whatever's here is not here, you put a 0 here. Okay, say that again. If whatever is here is not here, you put a 0 in that position. And if if what's here is here, you put a 1 here. Okay. No, there's nothing here, and there's a 1 here, so put a 0 here. These two are the same, so put a 1. These two are the same, put a 1. Not the same, put a 0. Not the same, put a 0. Same, put a 1. Same, put a 1, so on. Okay? That binary string, it's not a set, it's just a string. Okay? So it's a characteristic sequence. And it's characteristic of what? Well, of the language. Okay? Given the alphabet star. Okay. Now, can you see that given the language, there will be a characteristic sequence? Right? So, for any language written like this, there will be a characteristic sequence for that language. It'll be a one-to-one and onto mapping. So you can map. Now this is an infinite sequence. Right? Let's see. So if you have the set of all I'm thinking in real time here, because I've got to tie this up with B somehow. Now let me. So let's. Now we're trying to show that L and B, that there's a bijection between them, and we know that B is uncountable. Therefore, L would have to be uncountable. Let's see. Now, so assume a function that maps a set of languages into B, a set of infinitely long binary strings. Well, for each language, right? Here's an example of a language. And for each language, you'll have a characteristic sequence. Okay. Now, the characteristic sequence, they're all of the form. They're members of B, right? Can you see that? Because just an infinitely long sequence of ones and zeros, an infinitely long binary string. Okay. So if we map the set of all languages into B by the following definition, that now A, what's A? Well, that's just a member of L, right? It's a language. A is a language. And what's big L? What's the set of all languages? Well, therefore, this language A is a member of L, right? So if we define f of A to be the characteristic sequence of A, well, then you're mapping L into B. Make sense? If you didn't follow that, rewind. So the definition of this function is you take a language, any member of L, and the result of this function is a characteristic sequence. But a characteristic sequence is a member of B, right? So effectively you're mapping your A's into characteristic sequences. In other words, you're mapping members of L into members of B. Okay. Now, let's see. Now, why is that a bijection? Because for every member of L, you've got a member of B. Now, maybe that's not so clear. I still have a bit of a question mark on this. Why is this mapping a bijection? It's 1 to 1, you can see that. And why is it onto? Why is it onto? The set of all possible languages. Of all possible languages. Okay, I think I see. Right. The set of all possible A's, if you like. Well, you just you'd be modifying this appropriately. So for each A, and for each A, you're going to have a chi-A. Right. Yeah, and maybe